Hello and welcome to Drilling Insight. I'm Jeremy Verduzco, host and editor of the Drilling Magazine. I'm joined today by drilling trainer, the driller writer, and co-host, Brock Yorty. How's your day going, Brock?
My day's going excellent. It's about to get better. We got a guru on that's also a fellow Bronco, so this is pretty cool.
Which leads us into today's guest. We have Thom Hanna on the show. Thanks for being on the show, Thom.
I'm happy to be here. Always, it's a pleasure being on your show, and I'm looking forward to today's discussion.
All right, fantastic. Thom Hanna is an accomplished author and hydrogeologist who's worked at Johnson Screens for more than 20 years. But also has an extensive background as a consultant on well projects in water well, mining, and remediation. His books include working on the third edition of Groundwater and Wells, as well as the operational stage of the well. Now, we brought Thom back today to talk about droughts in part of the U.S., as well as other groundwater related topics. I'll throw it to Brock for the first question.
Excellent question here. Tom, did you choose this industry or did this industry choose you?
I actually chose this industry. So, as you're aware, but some of the other folks aren't, I started out as an exploration geologist and worked 6 years as an exploration geologist. But at Western Michigan, it was one of the few schools that had a hydrogeology program back in the early 80s. And I took all the hydrogeology classes and slid over into hydrogeology to work of all things at the mines and mine dewatering issues. So I could walk the walk and talk the talk both in mining and hydrogeology. So that's how I got to where I am today. But yeah, it's been an interesting ride, and I love using my geologic background in different ways.
So, I've read a lot this summer about kind of persistent drought issues in large parts of Arizona, California, Idaho, even Minnesota, Oregon, Utah, locally in other U.S. states. So, from a hydrogeologist perspective, how do these current drought conditions compare to earlier droughts that we've seen?
Yeah, well, I think the biggest issue is, yeah, we've seen droughts. They seem to be more intense. They seem to result in warmer temperatures. I'll just go there, global warming. And now that's stressing out the whole systems of, municipalities, small water systems. And so it's really a trickle down effect. It's not just the drought itself, it's also higher temperatures that are really straining these. And then you double on top of that. So let's look at Lake Powell. I'll just talk about something that's near and dear to us people in southwestern Colorado. We've had to empty a couple of reservoirs. So Blue Mesa Reservoir has had to be emptied to fill Powell because now the water levels approach the pin stocks, and Navajo too has been drained for power generation. And this is, directly drought related, but think about how that, pardon the pun, drills down into what we do. That's putting a stress on the water resources, which now are putting a stress on the wells. And so it's all connected. All these things are connected. So the drought is having a significant impact.
So we look at advances that we've seen in the last 10 years. How do you think that's changed the life cycle of a well? Like if we install a well today versus 10 years ago, how much more life can we get out of it?
Well, I think a lot of that has to do, so there's two parts to that question. In one part, we're seeing in Arizona, which is, and this is directly drought related. So places like Arizona, where the water levels are dropping significantly. And because the hydrogeology of the basins, originally those wells were shallower. So due to drought conditions, those wells are not deep enough now. And some of them that are deep enough, now we're drawing the water levels down into the screen sections of the wells. That is reducing the well life, causing issues with the pumping equipment, entrained air, and lack of production as well. So there's one side of it. So there is a depth component, if you will, or design depth component that wasn't anticipated when those wells were completed. So the second part is what I'd call materials issue. So some of those things I mentioned too, as the aquifers change, and if we are anticipating lower water levels, how do we change that design? One thing might be material selection, where before now we have oxygenated water coming into those wells. Maybe because for peak pumping capacity, we're willing to live with a well that has cascading water to meet those peak demands. And this relates back to what I was talking about before. So now we have warmer temperatures in the summer. We're having higher peaks. We're stressing the system. Now, and with ag wells, this is a common issue with ag wells. So now we're going to live with designs that have cascading water. That's going to reduce the well life. Now, are we going to switch materials that are going to be more corrosion resistant, knowing that's going to be just part of the norm moving forward?
Okay, so that feeds into my next question. So what kinds of changes to well design have you seen deployed in areas that are dealing with these kinds of drought conditions? Are there screening, pump, or kind of casing considerations that contractors need to think about?
Yeah, well, I think we have to look at the aquifer as a whole. And do we have more aquifer down below where we've traditionally drilled? And so that might be the case. Maybe we have to take water of lesser quality. And some of this water of lesser quality might have constituents that are very corrosive as well. And we're seeing more of that. So an example of what's happening there is if you look at El Paso, for example. El Paso is pumping water that has high chloride concentrations. So very corrosive waters. In fact, all of their wells top to bottom are now 316 stainless steel. So here is a engineering design to help extend the life of those wells because we're having to take water of such poor quality. And I think we're going to see more of that in different places. As part of that as well, we're probably going to start taking water, which may not be of chloride concentration, maybe arsenic or some other constituents that have been of concern. And so it'll either require treatment, blending, or some other things as well. So these are all drought related issues.
So, thinking of changing well design, what are your thoughts on synthetic gravel packs versus, the natural ones that we've been using for a century, right?
Glass beads in particular, is that what you're referring to? Yeah, so I think that's interesting on a couple of levels. One thing is glass beads tend to, when used in wells as a filter pack material, tend to produce wells that are more efficient, so we'll have less drawdown. If we want to keep on going down that road too, why are they less efficient? I'm doing some work at Cal State Fullerton. I have some students working on some studies there, some grad students. And I'm trying to unravel that. It's been kind of interesting. Some of my initial thoughts were, boy, glass beads must have a higher hydraulic conductivity or permeability. Where in reality, our initial studies find out they're very similar to naturally derived filter packs, especially at low. So under laboratory conditions, so that laboratory flow conditions where you test these kind of things would be like falling head permeameters, those types of things where you don't get into high pressures, high flows, but nonetheless, they're very similar. So I started thinking about that, and it's like, what's really going on here? Why do they develop up so much faster and more efficient? And so I'm coming back to, and my studies going forward are going to be focusing on, I think what's going on is that drilling fluids and fines do not stick to them. And so one of my mantras has always been, what's the most important part of well construction design? It's development. And what I'm thinking now is, because glass beads They do not filter, or excuse me, drilling fluids and fines don't stick to them. They develop up so much faster and thoroughly, where I believe there's probably half the wells that are drilled were never properly developed to begin with. So again, anytime we can make a more efficient well, we can meet those peak demands, we can have less drawdown. And so again, that's going to relate back to what we originally discussed, were droughts and how we can supply these peak demands. And I think that's really what it is in drought times. It's not the, the winter seasons or the wetter seasons we're talking about. What's really been affected is peaking. That's when we see these issues, is during peaking.
So you talk development, and that follows right into my big question. What is the most common mistake made when designing a well?
The most common mistake made. I'm going to change your question just a little bit. I'm not going to call it a mistake as much as how can we do it better? Okay. And I really believe if we start from day one in our design and we think about how am I going to develop this well and incorporate that into my design, you will have a very good well that is efficient and will have the longest life. So where all that starts, the whole development process starts in selecting your drilling method, in selecting your drilling fluids. And I think that's overlooked, that drilling fluids, the selection of drilling fluids, because the drilling fluids, they're very important. We've got to lubricate the bit. We've got to clean the hole. We have to maintain the integrity of the hole. And boy, that's a lot of asking for it. But the one thing we really have to ask is, how can we remove those? How can we set up that 1/32 of an inch filter cake, right? Something that we can remove and then restore that formation back to its original hydraulic conductivity right at that interface between the filter pack and the borehole wall. So that all starts with the design process, not with the construction process.
So, in these areas, I mentioned several states. There are plenty of water well professionals working in those states. So how do these professionals out in the field kind of arm themselves for the drought conversation with clients, whether they're residential clients, commercial clients, clients at a municipal level? Like, what can they do to help clients have realistic expectations about current and future well performance?
Yeah, I think that one's actually bigger than a drought issue, but it relates back to it. And what I'm going to say is, what the conversation we need to have is, what is the best value? It's a value proposition for all these well owners, whether it's a homeowner, a domestic well, a mine dewatering well, a municipal well. All those things is, we want to talk about a value proposition, not a cost proposition of what this well is going to cost today. So what is going to be the best value over the life of that well? So that's going to, if we look at it in the sense that, for example, a municipal well, and we want to have 100-year well life, which I don't think is unreasonable, maybe we should start looking at stainless steel casing and screens top to bottom. I think a lot of these municipal wells are stainless screens, but a lot of it's low carbon casing. I had an interesting, I guess, experience, if you will. I was working in Bolivia, and I was looking at a well design that was designed by some Israeli engineers who are very good at designing wells and are known for their hydrogeology. And my first reaction was, boy, they've designed this well for these Bolivians that really don't have that much money, and they've designed it 316 stainless top to bottom, and all the components 316 stainless. And my first reaction was, that's pretty expensive. Why? To me, it was almost overkill. And then I really started thinking about it. And I came back around. I said, they can't afford not to have it designed that way because it might be the last well they ever get. So my thinking is being from North America and a land of abundance, it's like, we just replace things when they wear out. But that wasn't an option. It may be the last well they ever get. So thinking back, what a tremendous value. And it's been kind of interesting. I've shared this story with some people in some local municipalities in Colorado, and now they're changing the designs of their wells to stainless casing and screen, where they've had some failures after 30, 40 years where the screens were fine, but it was the casings that were failing. And so it's kind of interesting. I think that impact of those Israeli designers has morphed through me and then on to some other people that I think are now designing wells better, and they're going to be the best value for that municipality and save that municipality a lot of money over the life of that system.
So we have you here, and this is the driller, and you got some time right now to stand up and say, "Hey, drillers, what would your advice be for something to adopt or a better practice that can take us into the 21st century?"
Well, a better practice, well, as a driller, number one, it's almost back to the future. I think back in the day, what day that was, 40s, 50s, 30s, you go back through some of those old drillers' journals, Johnson drillers' journals, all those, there was a real emphasis on development. And I think that actually goes back to cable tool drilling. A couple of things about cable tool drilling is, I think because of the time it takes to drill a well, they didn't think too much about, boy, I'm going to have to spend, weeks developing the well. And so the wells, I think, were much better drilled. I think also there's that drilling fluids component in there too. You don't have that issue as well, so they develop up a lot faster. But the other part of it is too, rotary drills, Brock, as you know, they're expensive machines. And if you're not out there making money with them, and development's not a huge money maker, right? If you're not constructing wells with them, it's pretty hard to pay those off. And so while they're very quick and efficient and they've allowed contractors to make more money, I think we really have to kind of look back at what we used to do in the past and how can we develop these wells up better using these new technologies.
That's absolutely true. The walking beam and surge block are things that is a lost art to us. And we have a writer with the driller that's been on a several issue discussion, John Schmidt, on cable tools and the importance of it. And that goes right into my last question for you. What's your advice for the next generation of well designers?
Yeah, so well designing is done typically by consultants, and you don't learn it in college. There's not a college that teaches, because college professors don't design wells, right? They're very good at numerical modeling and they're very good at the technical aspects, but there's hardly a college professor out there that's ever designed a well, because that's not what they do, especially, larger type constructions. So really it's up to the industry to teach that. And you need to go to classes that are taught by industry professionals that have done that work. And well, I'll just say it, and have made those mistakes and have learned and, have gone through that schooling. But it's, there are a couple schools, and you're going to be taking one in a week, but, take advantage of those things, because that's where you learn the practical side. It's not going to be college. And the other part of that is too, and I get it, I've been a consultant. Most consultants spend 90+% of their time perfecting water rights. And that's just the nature of the game. That's what they do. we're studying what's the aquifer yield going to be, what's this well field, we get a water right, and at the end of the day, we perfect the water right. And then the municipality gets to install a well. So they don't spend much time installing wells. So look to the people in the industry that can help you with those areas and look for those classes. You're not going to get it in college.
So we've talked to you a few times here at the Driller, including on one of the early videos of what became this video series, Drilling Insights. So we do appreciate you coming back. But when it comes to drought issues, kind of the severe drought they're seeing in California, Minnesota, Nevada, would you expect us to be having this same conversation when we talk to you in 5 years?
Yeah, again, it was interesting because there's just a very nice article in one of our local papers here too, and it was about the Colorado River system and drought effects. And in our lifetimes, can we reverse it? I think there is a big man-made component, and we are in it for the foreseeable future, whatever that means, my lifetime anyway. I don't expect things to change. And so, yeah, we better start planning around that. And I think there are more and more plans as more surface water, it becomes less available. We're turning to more groundwater resources. And all these things are going to come together. And it's a big issue. And we got to start planning ahead because, there is growth in the desert Southwest where this is happening. And so pretty soon the lines are going to cross supply and demand. I think we're pretty close to that point.
Okay, well, with that, we'll wrap up today's episode. So, Tom, I thought it was really interesting the point you made about uh, kind of we've picked over the low-hanging fruit of the groundwater that's available in some areas. So what we're getting is lesser quality water. I hadn't particularly thought about that in that respect. What do you think, Brock?
I think you're right. With the pumping we're doing, you look at West Texas, you look at Florida, there's several places in the country that we're getting higher and higher chlorides due to the withdrawal and the demand that we've gotten. Um, I think it's a great point, and we need to be environmentally responsible for our groundwater. I'm lucky I live in a Great Lakes state that Jeremy and I both live in. I'm not moving away from these bodies of water. I also thought it was really fascinating what Tom's doing with the students with the glass beads, and I had never thought about um, the bonding characteristics that we could have from drilling fluids or solids not wanting to be able to stick to them the same way as they would a traditional gravel pack with the charges we would have. And that has completely just changed my concept on all of that. So I'm excited to see where this goes next. And I appreciate you sharing that with us, Tom.
Yeah, what I think would be fun is in the future is maybe get a couple of these students on uh, and Richard Layton too. He's their professor, and talk about what we found out. I think that would be great for the students and for your audience as well to find out what's going on at the universities and some of the research being done.
And for anybody playing at home, Richard Layton also helped start the hydro field cap at WMU and is an alum as well. So those Broncos are out there.
Absolutely.
Okay, well, with that, we'll wrap up. Thanks again, Tom. Where can the audience find out more about you?
Good question. I'm available. We have a class, groundwater and wells class. We teach once or twice a year. Brock's going to be taking it in a couple of weeks. My email is thom@aqseptence.com. And I'm available for any and all questions. And I like to say, if I don't have the answer, hopefully I know who to send you to. So I like being a resource for people, and I'm just happy to be part of this industry.
Okay, well, you can find fresh episodes of our show on our website or on Apple Podcasts. Just search Drilling Insight and hit that subscribe button. And visit thedriller.com for the latest industry news and views. And of course, follow us on the usual social media channels. So until next time, this is Drilling Insight.